Hello and welcome. Have you ever looked at an object, maybe a rock or a piece of metal, and wondered what it's truly made of? Today, we're diving into a powerful technique that answers exactly that question. We're talking about EDX spectroscopy. EDX stands for Energy Dispersive X-ray Spectroscopy. That's a mouthful, so let's break it down. It's a method used to figure out the elemental composition of a material. In simple terms, it tells us which elements, like iron, silicon, or gold, are present in a sample and gives us a good idea of how much of each there is. Think of it as a chemical fingerprinting tool. So, how does this amazing technology work? It all starts with a very powerful microscope, usually a scanning electron microscope or SEM. This microscope shoots a highly focused beam of high-energy electrons at our sample. When this beam hits an atom in the sample, it can knock one of the atom's inner electrons right out of its place. This leaves the atom in an unstable state with a vacant spot. Nature doesn't like this instability. To fix it, an electron from a higher energy outer shell drops down to fill the empty space. As this electron falls into the lower energy spot, it has to release its extra energy. It does this by emitting a tiny packet of energy in the form of an X-ray. Here's the crucial part: the energy of that emitted X-ray is unique to the element it came from. A carbon atom will always release an X-ray with a specific energy, which is different from the X-ray energy released by an oxygen or a titanium atom. This is the unique fingerprint we're looking for. A special detector then collects all these X-rays and sorts them by their energy. The result is a graph, called a spectrum. This spectrum shows peaks at different energy levels. Each peak corresponds to a specific element. If we see a peak at the energy level for iron, we know there's iron in our sample. The height of the peak tells us about the concentration. A taller peak means more of that element. The applications for EDX are incredibly vast. In forensics, it can be used to analyze gunshot residue. Geologists use it to identify the composition of minerals. Art historians can analyze the pigments in a painting to verify its authenticity. In manufacturing, it's used for quality control, ensuring metal alloys and electronic components are made of the right stuff. It's a non-destructive technique, which means it doesn't damage the sample, making it perfect for precious or unique objects. In essence, EDX lets us peer into the atomic makeup of the world around us. Thank you so much for watching. If you found this explanation helpful and want to learn more about the fascinating world of science and technology, please give this video a thumbs up and consider subscribing to support the channel. Your support allows us to create more content just like this. See you in the next video.